In this question, we're given the curve y equals -2, x minus 3 squared plus 5. And we want to verbally state the transformations to the curve y equals x squared. Then we want to graph the curve showing each of the transformations that we describe. Okay? Well, here's our original curve, so we write that out. Y equals -2 times x minus 3 squared plus 5. Now, we see that A is equal to -2, H is equal to +3, and K is equal to +5. The reason for that is that we always write these as y equals A, x minus h squared plus K. So A is -2, H is +3 because it's x minus h and it's x minus 3, and K is +5. Okay? Well, when A is -2, what we start with is a reflection in the x-axis because A is negative. Then we also have a vertical stretch by a factor of 2. Once we've determined that, once we've described what the reflection is, once we've described that there is a reflection, we then look at merely the magnitude of A. And the magnitude of A is 2. And since the magnitude is greater than 1, we say that it's a stretch. If this magnitude of A, in other words the absolute value of A, if that had been less than 1, we would have called this a vertical compression. Okay? Well, we also have an H value of 3. See right there. When you have an H value of 3, that means we translate right 3 units. And finally we have a K value of 5, and that means we translate up 5 units. Okay? So we're going to go now to our graph, and we're going to see if we can graph each of these step by step. This is our parent function y equals x squared. That one never changes. Well, what we're going to do is start by dealing with this reflection in the x-axis. So I'm going to take each of the points here that I see, and I'm going to reflect them in the x-axis. Well, this point right here is -2, 4. So if I reflect it in the x-axis, instead of being 4 units above, it's going to be 4 units below. And this point is -1, 1. Well, instead of being 1 unit above, it's going to be 1 unit below. This point is 0, 0, so instead of being 0, it's going to actually still be 0, to be honest with you. Now this next point is -1, 1. Instead of being 1 unit above, it'll be 1 unit below. And this next point is -2, 4. Instead of being 4 units above, it'll be 4 units below. Okay? Notice we didn't change any of the x values because x is horizontal, and the reflection that we're talking about is merely a vertical one. Okay? So from here we can now draw what that curve looks like after a reflection in the x-axis. We've now dealt with this reflection in the x-axis. Done. Well, next we have to deal with a vertical stretch by a factor of 2. Okay, vertical stretch by a factor of 2. Well, right now we're not even going to consider this anymore. We're merely going to vertically stretch these, the points there, by a factor of 2. So here's how we do that. We're going to multiply each of the y coordinates that are now present, that are now on this newer curve, again ignoring that one, we're going to multiply them each by 2. So this y value here is 0. If I multiply it by 2, it's still 0. This y value is 1 unit below the x-axis. If I'm going to vertically stretch this curve, imagine it being stretched by a factor of 2, instead of being 1 unit below, it would be 2 units below. This point here is 1 unit below. Well, instead of being 1 unit below, it's going to be 2 units below. This point right here is 4 units below. Well, instead of being 4, if I vertically stretch by a factor of 2, it's now going to be 8 units below. Factor means multiply, so to vertically stretch by a factor of 2 means make everything twice as vertical. And finally, this last point here, we haven't done this one yet, This is 4 units below. Well, we're going to now make it 8 units below. Really stretch that thing out. And so now we have our 5 points now on this curve, and we can draw them like this. Okay, and we now have another version. We have the version of the parabola after the reflection and after the vertical stretch by a factor of 2. We've now shown that second transformation. We now want to translate this thing 3 units to the right. Well, the way we're going to do that is add 3 to each of the x coordinates. So this point here is 2 units to the left of the y-axis. I'm going to move it over 3 units and put it 1 unit on the right of the y-axis. This point right here is 1 unit to the left. Well, when I add 3 to it, it's going to be 2 units to the right. See, I'm moving this point 3 units to the right. That vertex is on an x value of 0. I'm going to move it 3 units to the right. This point here is on an x value of 1. I'm going to move it 3 units to the right. Now it's on an x value of 4. And this point right here is on an x value of 2. I'm going to move it 3 units to the right, and now it's on an x value of 5. And so now I graph that curve, that one. And what I've got now, what I've got is what the parabola looks like, other than that point which I missed. I've got what the parabola now looks like after the third transformation. Okay? And my final one I have to deal with is to translate up 5 units. So I'm going to translate that up 5 units. And so that just means every one of these points is going to get moved up 5. So this point right here gets moved up 5 spots to right there. This point right here gets moved up 5 spots to right there. That point is moved up 5 spots right there. This point is moved up 5 spots. And finally this point is moved up 5 spots. And I've got a new parabola right here. And because it's my final one, it's the final end product, I'm going to do it in a different color. I like to show it in a different color. And it looks like this. And so what we've done is we've shown all the changes that took place. Change means transformation. All the changes that took place. The reflection, the stretch, the translation over, and the translation up. And the final curve, the curve y equals 2x minus 3 squared plus 5, is the blue one.